Welcome. Today, we're going to pull back the curtain on the set of rules that makes our entire modern internet tick. And if you're in the library and information science world, trust me, understanding this is key to pretty much everything we do with digital information today.
So let's start with a question we almost never stop to ask. You click a link, you send a huge file, how does it just appear, like magic, on the other side of the planet? Well, spoiler alert, it's not magic. It's an incredibly organized and honestly a pretty fascinating process.
The best way to get our heads around this is with a simple analogy, a global postal service. I mean, think about it. If you need to send something huge and really complex, you can't just stick it in a single envelope and hope for the best. You need a system. And for the internet, that system is called TCP/IP.
So here's our game plan. We'll kick things off by defining the internet's rulebook. Then we'll use our postal service analogy to break down the 4 technical layers. After that, we'll properly introduce the 2 stars of the show, TCP and IP, and then tie it all back to why this is so critical for LIS professionals. And we'll wrap up with one key takeaway.
All right, let's dive right into the deep end. What in the world is TCP/IP?
Okay, so first things first, it's not one single thing. That's a super common misconception. TCP/IP stands for Transmission Control Protocol/Internet Protocol, and it's actually a suite of rules. Think of it like the ultimate instruction manual that every single device on the internet has agreed to follow. It's what makes sure your data gets from point A to point B reliably, and it doesn't matter one bit what kind of computer you're on.
And that right there is its superpower. TCP/IP isn't owned by some big tech company. It's non-proprietary. It's an open, universal standard. That's the reason your Mac can talk to a Windows server and your Android phone can pull up a web page from a Linux machine without a hitch. It is the very foundation of the open internet we know and love.
Okay, so let's get back to our postal service analogy, because it really helps make sense of how all this works in the real world.
So picture this. You have to mail an entire 30-volume encyclopedia set to a friend. You obviously can't stuff that into one box, so what do? Well, first, you have the content itself, the encyclopedia. Then you have to break it down into smaller, easy-to-handle boxes, and you number them. Box 1 of 30, box 2 of 30, and you get the idea. Next, and this is crucial, you put the destination and return address on every single one of those boxes. Finally, you hand them all over to the Postal Service to ship them out on their trucks, planes, and ships. Just keep that whole process in your mind.
Now for the really cool part. Let's see how that whole Postal Service story maps directly onto the 4 technical layers of the TCP/IP model. This is really where it all clicks into place.
We're going to start at the very top, at layer 4, the application layer. This is the stuff you actually interact with. Your web browser using HTTP, your email program using SMTP, you name it. In our story, this is you and the encyclopedia. It's the actual information you want to send.
Next up, your data gets handed down to the transport layer. This is where the T in TCP/IP, the Transmission Control Protocol, does its thing. Its main job is reliability. So just like that super organized postal clerk, TCP takes your giant encyclopedia, your data, and chops it up into all those little numbered packets. It keeps a list of every single one to make sure they can be put back together perfectly at the end.
So now that we have all our numbered boxes, they head down to the internet layer. This is where the famous Internet Protocol, or IP, lives. And its job is pretty straightforward: addressing. This is where every single packet gets stamped with that IP address, the specific digital destination and return address for every single box. It tells the network exactly where to send it.
And finally, we hit the network link layer. This is the physical stuff. We're talking about the Ethernet cables, the Wi-Fi signals, the fiber optic lines. In our analogy, these are the actual mail trucks, the planes, and the roads. This layer is what physically moves those addressed packets across wires and through the air.
So, let's really zoom in on the difference between those 2 main players, TCP and IP. It's so important to get this. They work together as a team, but they have totally different jobs.
This division of labor is absolutely genius. Think of IP as the mail carrier. Its only job is to take one packet and get it one step closer to its destination. It doesn't guarantee delivery, it doesn't care about the other packets, it just sends. But TCP is the manager, it's the responsible one. It establishes the connection, sends all the packets, double-checks that they all arrive safely, and then puts them back together in the right order. So in short, IP just gets the mail out the door, TCP makes sure the entire encyclopedia arrives intact.
Okay, I know, that was a lot of technical detail. But why is this whole digital postal service thing so important for those of us in library and information science?
Well, because TCP/IP is the invisible engine running behind almost everything you do. That remote access that lets a user tap into your library's catalog from home, that's TCP/IP. Those precious high-res scans in your digital archive, TCP/IP is what ensures they get transmitted without a single bit of corruption. And with so much library data moving to the cloud, TCP/IP is the language our systems use to talk to those services. And at the end of the day, understanding how your data moves is step one to securing it and protecting your patrons' privacy.
Okay, let's boil this all down to the single most important idea I want you to walk away with today.
If you remember just one thing, let it be this. TCP/IP is this amazing, invisible, and scalable framework that allows our incredibly diverse digital world to actually connect. It works no matter the operating system, linking all these different computers together without us even thinking about it. It truly is the quiet hero working behind every single click.
So, I'll leave you with a question to chew on. Now that you know how our information is actually broken down, addressed, and then reliably put back together, how does that change the way you think about digital preservation, or about network security, or even about providing access to your collections?
Hey, if you found this explainer useful, go ahead and hit that like button, drop a comment with your thoughts, and of course, subscribe for more content made specifically for library and information science professionals. Thanks so much for tuning in.